Hello everyone, and welcome to lesson number 2 in the Practical Python video series. Just to recap, thus far we have learned about the basics of variables, loops, and if statements. So all we can do so far is what I would call a straight shot program. The code just runs top to bottom, you set some variables, and they sort of trickle through all of the if statements and the loops and everything. Variables get set and reset and assigned to new things. You can print stuff along the way, and that's about it. We can't really do anything particularly useful or interesting yet. This lesson we're going to start to get into some more useful stuff. So we're going to start this lesson off with functions. These are very, very important. Everything that we've learned so far with if statements and for loops, I would say 90% of the time you're not going to just put them just in the code like we've been doing. They're going to be within a function because you're going to be wanting to run those loops and if statements more than once. And a function makes it so you can run that code whenever you want without having to copy and paste that for every time you want to run it. So just a very basic function to start. The way to do this is def. We are defining a function, and I'm just going to name it, this is a function, parentheses, colon, kind of like with the if statements and the loops. And then this function is just going to be a print statement. It ran. And now we are going to run the function. So what's happening here is we're defining a function. This is the name of the function. Same kind of thing as with if statements and loops, where you indent here and then whatever is in here is going to be within this function. And then this is how you run a function. You just say the name and have the parentheses. So if we save this and we run it, see in the console it ran, yay. To show you sort of the point of functions, I can just copy and paste this a bunch of times. Save and run that, and it ran 4 times. This is obviously just a print statement, so in this case it would be easier to just copy and paste this a bunch of times or have break lines or whatever if this is what we were after. But if we had loops and if statements and all kinds of stuff in here instead of just a print statement, you can see how this would save you a lot of space, save you a lot of time. It would condense your code a lot to be able to just say the name of the function and then that function would run, instead of having to put this inner block a whole bunch of times. Now this is a function that just sort of runs. We just say the name and it runs. But generally you're going to be doing what's called passing. You're going to pass something into the function, and then the function is going to do something with that. So here we'll just do that. We'll do I am an argument. Oop. There it is. I am an argument. So when you put something in these parentheses here, these are going to get passed in as what's called an argument. This is basically a variable. A variable is going to get declared every time this function runs, and then within that function you can use that variable. So in this case we're just passing in a string for the argument arg. You can think of it as like this is the name of the variable and then this is the value of the variable. So save and run that. I have an argument, yay. A more interesting example, well, slightly more interesting, we could pass in like a number, and then we're going to say x equals arg plus 10, we'll say, and then print x. Save and run that. We get 17. So we're passing in 7. 7 becomes the value of arg. X equals arg, which is 7 plus 10, so then x is going to be 17, print 17, and that's what happens. You should start to see now how you can have more and more complicated and useful and interesting functions that do more than just add 10 to a number or just print something. Something else we might want to do is returning. So instead of you don't usually print something when you have like a program that other people are going to be using or something that you actually want to do stuff. You're going to be returning things. So let's do return x. Then we'll say y equals, this is a function of y, and then we're going to print y. Save and run that. We get 17 again. So now to go through what's going on. You may remember, like from math class, depending on who you are, they would say y equals x squared or something like that. And then at some point in your education they should have said another way of writing this is f of x equals x squared or whatever function of x. So the value of f of x becomes whatever you plug in for x, and that's exactly what's happening here. So we're plugging in 7 for arg, x becomes arg plus 10, so that's going to be 17, or whatever is happening here. We're just adding two numbers, but we can be doing other stuff. And then we're returning x. This means that the value of this entire function becomes whatever we're returning. So when we say y equals, this is a function of 7, we're sort of in a roundabout way of saying y equals 17. An important thing to note, anything that you put after the return statement in a function doesn't get run. So if I print save and run that, hello doesn't get printed. As soon as a function is told to return something, that's it. It kills the function basically. It doesn't bother with anything after that. So sometimes you'll pass in something for an argument, and here we'll show you. If arg, or no, we'll do if not arg, then return none. And then we'll do z equals and then we'll just pass in nothing. Wait, we have to pass in something. There we go. So what's happening here is we're passing in 7 for arg. If not arg, then return none, but there is arg. If you'll remember from the last lecture, 7 is a thing, it's not none. So this code doesn't run. We're not returning none. X equals blah blah blah, it's going to be 17, return 17, and that's fine. And then we're running this function again, except this time we're plugging in none. So we plug in none for this, if not none, so none doesn't exist. So then this condition is met, this becomes true, and we're returning none. We don't try to add 10 to none because that would throw an error. We don't return x because x hasn't been defined. All of this just gets ignored because we have this return statement. And this is pretty common practice. The first couple lines of a great big function, something much bigger than this, will be make sure we can actually run the function, make sure that's what's being passed in makes sense, and if it doesn't make sense, just return none. So we don't bother going through all of this code that we know isn't going to work. I just want to give you a little bit more useful example of a function, just so you can see. We'll do O, and then by there. So we've declared a variable x equals this list, and we'll do this. There we go. We'll do y in arg if len of y is, I don't know, less than 5, then print y. And not here, we'll make it even more interesting. Count equals 0. There we go. And then we're going to do y equals, this is a function of x. Run that. So, what's happening here is we've declared this list equal to x. We are passing in this whole list as x. Well, we're passing this whole list in, calling it x, as arg. We are making sure arg exists. If it does not, then return none, but it does because we're passing in this list. We are declaring a new variable inside the function, calling it count equals 0 for y in arg, meaning y is going to be hello, and then bye, and then Alan, and then Jake. If the length of y is less than 5, so that's going to be everything in this list other than hello. Hello has 5 letters, this has 3, 4, and 4. If the length of y is less than 5, then print it, and then add 1 to count, which we already said was 0. So this thing is going to count how many words in this list have less than 5 letters, and then we're going to return that count. So that's going to be 3, because there are 3 in here that have less than 5 letters. So you can see here, it does not print hello, because hello has 5 letters, 5 is not less than 5. It doesn't print hello. It does print bye, and then does print Jake and Alan. Count is going to be 5, count is going to be 3, it returns 3. And then down here, we print 3. So there you go. I hope this kind of gives you an idea of how functions can be more useful than just setting and printing variables. Here we're counting things. This is something that we might not know ahead of time. I mean, we can look at this list and, okay, yeah, obviously there are only 3 things in here that have less than 5 letters, but this list could have 500 names in it, and maybe we wanted to count the number of vowels or something like that. But we could theoretically actually want to do something, and we didn't know the answer when we started. This is an example of that. Thus far, you pretty much, if the fact that you're writing the code means that you already know what's going to happen, if all you know is what we learned in the last lesson. One last thing with functions, and then we're going to move on, is the idea of scope. So here we're going to say x equals 5. I'm just going to call this func arg, and then we're going to say x equals 3. Then we're going to run func. Actually, we can get rid of this for now. And then print x. So looking at this, if you've been following along and have understood everything, you should say, okay, x equals 5, we're defining a function, doesn't take any arguments. We're now setting x equal to 3. So x is 5, we have this function, we're running this function, so now x should equal 3. And then when I save and print this, we'll do that now, it should be 3. But it isn't, it's 5. You say, what the heck, we ran this function, x should be 3, what's going on? What's happening here is these are actually two different x's. This x is declared outside of all the functions and everything. So this is what's called a global variable. And this is in the global scope. This x in here is in the local scope. That means that this function does not know about this x. It sees this x. If we want it to be talking about, and there are times that you'll want to do this. You'll have maybe you have a whole bunch of, we'll say x or something, because you have a whole bunch of different for loops in every function, and they all use the variable x, and you don't want them to sort of mingle. You don't want one to be using the x of another variable or whatever. This prevents that. The function doesn't look outside of itself for an x if you give it an x. But if we want it to do that, say the word global x. Now if we save and run, now we get 3, because you're saying here, okay function, look at this variable. This is the x I'm talking about. Set x equal to 3. Set this x equal to 3. Don't set your own x equal to 3. An interesting thing, the Python is smart in a way in that if we say print x here, save and run, it prints twice because we have two print statements. We didn't give function a local x. It doesn't have its own x. So when we tell it to print x, it knows that we're talking about the global one. We don't have to put the word global in this instance. However, an error that you would find very confusing if you weren't aware of scope and globals and locals and everything, we do x equals x plus 1, and we run function. You would expect this to say, okay, I have x equals 5, and I just want to, every time I run this function, I just want to add 1 to 5. So I run this once, it's going to be 6, I run it again, it's going to be 7, and so forth, for whatever reason. Maybe you're counting something or whatever. But if we run this, we get an error. This is because Python sees x equals and says, oh, okay, I know that this function, we're giving it its own x. It has its own local x. And then it sees x equals x plus 1. It doesn't know what this is. It doesn't know that we're talking about the global one. It says, it has its own local x, but that hasn't been defined yet. If we say like x equals 2 or something up here, save and run that, that's okay, because now this x is defined. So this x is down here, now x is going to be 3. The local x is going to be 3. But without that, it's trying to set a local variable equal to itself plus 1 when there is no local variable, if that makes sense. So this is another instance where we would have to do global x, save and run. Now x is 6, because x is 5, talking about the global x, just add 1 to it, run that function, there you go. Be aware that you can pass in more than one argument if you wanted to. So we could do, z equals arg1 plus arg2, and then we could pass in, we'll get rid of this, we'll just print this. And now we're going to pass in like 2 or 3 and 4, save and run that, we get 7. So if you want to pass in more than one argument, you separate them by commas. Know that you can pass in whatever you want. This could be an int, this could be a string, you can be boolean, whatever you want. You can actually pass in the values of other functions if you want. So do func2 of whatever. We'll do this. And this is an example of how I see both of these have arg1, but they're not aware of each other. to return R1 plus 3, we'll say. And then we can do func of 3 and func2 of... This is sort of a messy example, but this is a good example of what real code is going to look like. We save and run that, we get 14. So what's happening here is we've nested these functions. We're passing in 8 for arg1 of func2, return, so the value of func2 of 8, that's what the return is doing, is going to be 8 plus 3, so that's 11. So then this whole thing becomes 11. Now we're passing in 3 and 11 into func. Z equals 3 plus 11. Print that, so 3 plus 11 is going to be 14. So that's how you can have functions be arguments of other functions. So now we're pretty much done for functions. You know everything you really need to know for now. Now we're going to talk about objects. So I'm just going to copy and paste into here. This is just about the most basic example of a class of an object you can possibly have. When we say class of whatever we want to call it, object, you just always have to have this here. This is like a blueprint of the object that we want to make. So this is, you always have to have this function within the class. This is going to run every time you make what this blueprint says to make, basically. So you can see down here, I'm declaring a new variable, my instance equals my class, and then I'm passing in this string as an argument. So every time I run my class of whatever, I'm making a new instance, it's called, of this class. You can think of it as we have a blueprint for a car, and then I'm saying like Jerry's car equals make this car, and then I say Tom's car equals make this car, and whatever. I keep running this class thing over and over, and each time I do that, I'm making a new car or whatever. I'm making a new instance of that class, and I'm passing in this string, the best name. You'll notice that this is one argument, this is one string, but in here we have two arguments. It's self and name. The self one, you always have to have whenever you have functions within a class. They always have to have self as the first argument, and then you just kind of ignore that when you're passing stuff in. So this string here is getting passed in for name. And then here we're setting a property. We're saying self.name equals name. Python is not really object-oriented, but you can think of it as being object-oriented. And all that means is the dot. If you go to a computer scientist and you ask what object-oriented means, at least everyone I've talked to, they literally just say dot. It means the dot thing. It means that we can do this. So if I save and run, just so you can see, it prints the best name. We are making an instance of my class. It's setting its own name equal to this thing we're passing in. And I can change this to something else if we want. We can just make this arg. It doesn't have to be the same thing. Run that just so you can see. It's setting its own property name. We can make this whatever we want to. Name isn't like a special Python thing. I just made that up. Setting the value of its own name equal to whatever we passed in. So my instance.name equals that. Another example, just to give you an idea of instancing, we can do my instance2, and this is the bester name. Print my instance2.name. Oh. Run that. You get the best name and the bester name. Even though we have one class, we're making two instances of this class, and we're setting each of their name properties equal to these two different things, and then we're just printing them. This is really useful, the idea of classes, because you could have like maybe you're making a system to keep track of cars at a dealership, just to go back to the car example. You can say class is car, and we're going to say this is the brand, and this is the year, and this is the owner, and then you say self.brand equals brand, and so forth through all of this stuff. And then you can just pump out as many of these as you want. You can have a button or a text box where you enter stuff into a program that you made, and you can make it so that it will just add a car to the inventory, the virtual inventory with whatever parameters you set. So we can say like car1 equals car of, it's going to be a Chevy, and it's going to be 1980 whatever, and it's going to be Tom's car. There you go. And just to show you what happens when you print out a whole object, do that. It's kind of useless. It's, yeah, you pretty much only want to print properties. But by doing this, you could have all of these in a list, all of these instances of the car class in a list, and then with for loops or whatever, you can go through and you say, I want all of the cars that are a Chevy, or you want all the ones made from before this year. In fact, we can make this an int. So then we could do like less than or greater than on that. You want all the ones that were owned by this guy, or you could have another property that was previous accidents, and you could get ones that had whatever property with that. Classes and instancing are just a really nice way to organize your stuff and handle lots and lots of data. Or if you just want to have, I usually write a program with one class at the top, and that just has all of the global variables in it. So yeah, here we're going to show a little bit more involved example of a class. I just copy and pasted just so I don't have to type all this out, but I'm going to explain what everything is. Here, we'll put spaces in between things so it's easier to look at. So I'm defining a class. This init function runs whenever we make a new instance of the class, passing in these two arguments, so self.name equals name, self.myProperty equals myProperty, and these could be like, this is how you would usually do it. There you go. So the values that are getting passed in here are getting set equal to these two properties. And then you see here, I'm setting another property, self.myChildren equals, and then just this empty list. And then I have these other functions in here, rename, setProp, addChild. We'll just do one for now. So I'm making a new instance of this class, passing in a name and a property. It's just a random float, whatever. And then I can do stuff to that instance. I can run these functions, and these will only run for that instance. So here, you know what we'll do? instance 1, my instance 2, and we're going to make this that and that, and then we're going to do my inst 1 dot rename name and Tom. And then of course we can just print both the names. Okay, and then we're going to run it. So what's happening here is we're making two instances of my class, passing in Alan and whatever number. We can make this something else if we wanted. And then making another instance, passing in this and this. So the first one's name is going to be Alan, and its my property is going to be 72 point whatever. And then the next instance is going to have the property name Jake. The other one is going to have my property of 12.8. And then we're running this function, but only on the first instance. So instance.rename, we've defined this function in here to be, again, we always have to have self. Whatever we pass in, self.name equals new name equals whatever we pass in. So we're renaming the first instance to be, with the parameter Tom. So it's setting its own name property to be Tom. And then we printed those, so you see it says Tom and Jake. Notice that the other one wasn't changed. And this would be useful for, just going back to that car example, if you wanted to change the year, change the owner or whatever, or maybe you have a database of stuff for a phone company and somebody added a phone to their plan, you would just run functions. You wouldn't make a whole new instance of the class. You would just run these functions from within each instance to edit little things. And you see this thing self.children equals this empty list, and then I have here add child. We can do something this is something very powerful that you can do in object-oriented programming. So what's happening here is I made an instance of a class, I made another instance of a class, and now I'm passing in that second instance into this function that's running within the first instance. So the second instance is getting passed in for child. We've basically made a new data type with this. You can think of you're passing in an integer or a boolean or whatever. Now we're passing in an instance of my class as a variable. So passing that in for here, self.children.append. This is a built-in function with lists. This is if you want to add things to a list while your program is running. It's called at runtime. You want to see that? That's just, should have gone over this before. Say 2, 3, 4, and then you can do like x.append 5, and then if we print x, you get 2, 3, 4, 5. This is just a way to add things, and if you Google it, they're all different things. If you want to remove specific things, or like if we wanted to do x, the second instance is 1, and then we do that. We made 4 equal 1. We just swapped it out. Anyway, we had this list. It's a list of objects now, not just integers or whatever. So then we can do print myInst.children, get the first thing in that list of children, name, and we run that. We get Jake because we're in my instance 1, my inst1, whatever, dot children, so we're talking about this list, the first child in that list, the first element in that list, so that's going to be my inst2, and then we're talking about my inst2 dot name, which we already declared to be Jake, so there's Jake. This could be useful for, you have buildings within buildings within buildings, or whatever, or if you have stuff with your program, just from within your program. You can have a menu within a menu, or there's like a button in a menu, or whatever. This can be very, very good for organizing stuff, so your code is more readable, more manageable. If you want to add features later, you want to have updates, using classes and objects makes updates much easier. You can have these return stuff if you want as well. That's a way to be more secure, I've heard. I've never really had any kind of a problem with it, but you could just do, instead of this rename function, you could do like, just get rid of all this, my inst1 dot name equals, and then something else. You could just do this instead of having this function in here and running it. For one thing, you're usually not just going to have one line in here. You're going to have, it's going to be more complicated than that. So running that function will save you space anyway. But additionally, you can have checks in here in this function to make sure that whoever is trying to rename the thing or is trying to do whatever is someone that's supposed to be doing that. You can have it so it's like an admin, somebody with certain privileges. The owner of the car dealership is the only one that's allowed to change the years on the cars or something like that. You could have another object that was like user, and it would be their name and whether or not they were a customer, a worker, or the owner. And then in here you could check to make sure they were the owner, and then if they are, then change self.name to new name, something like that. You can just be much more secure if you have stuff like this instead of doing this. And that's about it for functions and objects and classes and all that. You can now make actually useful programs. You could make a like you can make a text-based video game. I used to make them when I was younger. You have a class that's your player, and then you could have like their inventory, whether or not they're hurt or not. I remember I did stuff like I had a variable like has torch, and then that would be a boolean, and there was a function where the player would try to go into a room, and if it was like a really dark room, it would say it would check whether or not the player had a torch, and if they did, then okay, you can go into the room, and if it didn't, it would say no, it's too dark, you can't see anything, you can't go in this room, or like a key to a door or something like that. You can make systems to organize stuff. You can make sort of databases now, and even more so in the next lesson when we talk about external files. So I hope you found this informative and interesting. We're really gaining momentum now, really learning real programming, and I hope you enjoy the rest of the series as well.